So in this video, let us discuss one more problem regarding conversion of Epsilon NFA to DFA. This particular problem has been asked in the VTU examination question paper. So let us solve this. Now we have the Epsilon NFA diagram in front of us. Now here we can see this is the start state and this is the final state. Okay. Now first of all we are supposed to build the transition table. Now let us build the transition table. It will be delta, okay, then upon A, then upon B, then upon epsilon. So this is our transition table. Now first is state 0, which is starting state. 0 on A is 1, 0 on B we don't have, and at the same time we don't have 0 on epsilon. Then state 1, 1 on A we don't have anything, 1 on B is 2, 1 on epsilon we don't have. Next 2, 2 on A is null, 2 on B is also null, 2 on epsilon is 3. Then we have state number 3, 3 on A we don't have anything, on B also, 3 on epsilon is 4, 6, because 3 on epsilon is 4, 3 on epsilon is 6, so 3, 4, 6. Then we have state 4, 4 on A is 5, 4 on B we don't have, 4 on epsilon also we don't have. Then we have 5, 5 on A we don't have anything, so it will be null, null. 5 on epsilon is 8. Next 6 on A is null, 6 on B is 7. Okay. 6 on epsilon we don't have anything. Then 7 on A nothing, on B also nothing, on epsilon it is 8. Okay. Then we have state number 8, 8 on A nothing, also on B nothing, 8 on epsilon goes to 9, and from 9 we don't have any transactions. So this is our transition table with respect to the given Epsilon NFA. Now second task, let me start from here. Okay. We are supposed to find the epsilon closure of each and every state. So epsilon closure of state 0. See, epsilon closure of any particular state will be that state itself, along with, if at all that state has taken any epsilon transitions from that state to some other state, that also we have to include here. Now epsilon closure of 0 will be 0. There is no epsilon transitions from 0, so it will be 0 only. Epsilon closure of 1 is 1 itself, then there is no epsilon transitions. Then epsilon closure of 2 will be 2 itself. See, here we have one epsilon transition from 2 to 3, so 3 also will be included. From 3 to 4, once again we have epsilon transition, that also has to be made union. Okay, so we will have 4 as well. See, once again from 3 to 6 there is epsilon transition, so 6 also we have to include. And there are no more epsilon transitions from 2. Next, 3. So I hope you understood now how to build the epsilon transition set. That is 3 itself, then 4, then 6. Then we have epsilon transition of 4, that is 4 itself, epsilon transition of 5, that is 5, then 8, then 9. I hope you understood this, why it is 5, 8 and 9. Then epsilon transition of 6, it is 6 itself, epsilon transition of 7, it will be 7, 8, 9, epsilon transition of 8, that is 8 itself and 9. So this is our epsilon closure of each and every state. Now we are supposed to find out or build a table that represents the DFA. So in this table we are going to, this is a transition table once again, we are going to avoid epsilon transitions. So delta, okay, delta, then A, then B. Now let us take the first state, that is 0. Okay, so 0 on A, 0 on A, 0 on A, that is 1. Okay, so state is 1, and 0 on B, it is null. So we are supposed to take these states, okay, starting from 0. Now we got one more new state here. We have done for 0, now for 1. So 1 on A, 1 on A is null, okay. Then 1 on B, it is 2, this one. So instead of writing 2, we are supposed to write epsilon closure of 2. That is, epsilon closure of 2 is 2, 3, 4, 6. So this comes into picture. 2, 3, 4, 6. So be careful here. Don't directly write 1 on B, that is 2 actually, but 2's epsilon closure we are supposed to write here. Okay. So we are done with 1. Now we got one more new state here, that is 2, 3, 4, 6. Now 2, 3, 4, 6 on A. See, 2 on A, 3 on A, 4 on A is 5, 6 on A is null. So only 5, that is what we are getting here. So 2, 3, 4, 6, 4 on A is 5. What is 5's epsilon closure? It is 5, 8, 9. 5, 8, 9. Similarly, 2, 3, 4, 6 on B. See, it is null, 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 and it is 7. So what is 7's epsilon closure? It is 7, 8, 9. 7, 8, 9. So this is how we are going to build the transition table. See, now we are done with 0, 1, 2, 3, 4, 6. Now we got new state 5, 8, 9. So 5, 8, 9. Now 5, 8, 9 on A. 5 on A, null. 8 on A, null. 9 on A also, null. Okay. Now 5, 8, 9 on B. 5 on B is null. 8 on B is null. And 9 on B is also null. So we don't have any particular transition there. So 5, 8, 9 is over. Next is 7, 8, 9. We have 7, 8, 9. Now 7, 8, 9 on A is 7 on A, 8 on A. That is also null. Okay. Next 7, 8, 9 on B. 7 on B, 8 on B is also. So we have 1, 2, 3, 4, 5 states. Now, as we have covered transition for all the states that we have here, and we are going to end up with this transition table for DFA. This is our transition table for DFA. Now let us see how we can draw the final DFA for the given Epsilon NFA with the help of the generated table. Okay, now I will draw the final DFA that is obtained using this transition table for Epsilon NFA. Now let me first put the states. State we have is 0, 0. Then we have 1. We have 1. Next we have 2, 3, 4, 6. We have another state. Then we have 5, 8, 9. 5, 8, 9. Then we have 7, 8, 9. 7, 8, 9. Okay. Now we know that this is the start state, 0. And wherever you have 9, you can make it as final state. This is also final state. Okay. Then we have one null state. A null state. We can also call it as trap state or dead state. Okay. Now 0 on A, it goes to 1. 0 on A goes to 1. 0 on B goes to null. Okay. Next 1 on A goes to null. Next 1 on B goes to 2, 3, 4, 6. Okay. Next 2, 3, 4, 6 on A goes to 5, 8, 9. 2, 3, 4, 6 on B goes to 7, 8, 9. Next 5, 8, 9 on A as well as B goes to null. 7, 8, 9 on A as well as B goes to null. So this is our final DFA for the given epsilon NFA. I hope you have understood. Thank you.